Hey guys, welcome back. We got Mr. Bin and Mr. Baldwin here helping you through our next segment. If you want to take a quick review, we've got the 12 learning objectives from the last time, and we're actually covering numbers 9 through 12 in this activity. So take a second, read through a couple of them, and make sure you know what you're expected to know out of this activity. You might want to pause the video right here just to take a couple minutes to read over them.
Welcome back, everyone. Mr. Z and I talked to you in the last segment about some of these reversals. So we want to see if we're really understanding, take a chance to quiz you if you're understanding what you're actually seeing here. So where would the more be on this? Where do you think that would be?
So we need to find a pattern somewhere in here where we see the same things on both sides. Okay, so to me I'm seeing, correct me if I'm wrong, would it be all the way at the top? Because I don't see any patterns on both sides. And I'm looking at present, and that's the most current time that we see here. So if you look at present, that's got to be in the middle of the mid-ocean ridge.
Oh, so you don't always have like some segment in the middle and always showing it going away. In this case, there would be a mirror image of this going that way.
Yeah, if we looked at the other side, actually you would see the absolute reverse all the way up on top. So this bottom part is just one section that's on one half of the mid-ocean ridge.
Okay, and so present, this would be how the magnetic field is currently lined up. So that would be normal, so the light color. And then the dark band, that would be...
That'd be a reversal, yeah, so absolutely. So as you get older, you go from a normal to a reversed, and then you actually go back to a slight period of normal, and then you go back to reverse. They call it the Matuyama reversed period.
So basically you're always seeing this pattern of white, black, white, black. And those same thickness of bands would be the same on the other side of the mid-ocean ridge.
Yeah, so hopefully that should be a review from last time.
And that those took certain periods of time to happen.
Yeah, it's not always the same amount, but on average, as we can see from here, takes about 500,000 years for those reversals to take place.
Okay, that makes sense. Now, these look like pretty artistic pictures that we're looking at here.
I spent hours drawing these things. Broke a lot of crayons doing these.
Looks like your spirograph was getting a workout. But aren't those actually like images of what it would look like when the field lines come out of the Earth?
Absolutely. If you take a look at it, on this one up in the upper left-hand corner, you can see that the orange ones pointing from the south pole of the Earth are actually pointing up and then back into the top, the north end of the Earth. And so that's actually showing a normal direction of a compass. So south is on the bottom of the Earth, north is on the south.
So your compass would point towards the North Pole where the arrows are going in or the field lines are entering.
Absolutely. And so it's going to stay like this for about 500,000 years on the average. It's going to be off by a little bit here or there. But as you can see, if you move to the second image, the one in the middle and on the right, you actually see it starts to shift a little bit. It's starting to kind of tilt towards the side, or tilt up a little bit. And then the final picture actually completely reverses direction. So now you're coming out of the North Pole and going into the South Pole. So we actually had a reversal that took place on this one about every 500,000 years.
So a compass would then point to the south there, showing where they exit the Earth, as opposed to the north and the normal when they come back in.
If you were looking for directions, it would be a really confusing time period because you would walk north, but you would be heading south at that point.
That'd be crazy.
That'd be nuts. It would be a really fun time, though.
Ooh, I like this one. This shows Harry Hess's boat or something that he would have used. So he would be towing behind him a magnetometer. Fancy term, so basically a device that looks at the magnetic field strength?
Measures the magnetic field, what direction and intensity you would see.
Okay. So they tow this boat over one of these moors, and as they do, on the screen, those up and down, that's like when you're flipping strong, weak, like north, south, north, south.
And as you can see, he went over his mid-ocean ridge right here, and if you drew a line, you should have a nice reversal, a mirror image on either side of these, the mid-ocean ridge. So you've got the whites, you've got matching blacks, then whites again, blacks again, whites, blacks, whites, blacks. And it'll go all the way across the entire plate.
So it probably would have been pretty interesting in their boat. They noticed, okay, you've got a band, then it switches. And then a band, switch, band, switch. And then in this one, they might have expected it to switch earlier, but then it maybe stayed a little extra long as they wound up on the other side. And then it had the same pattern as the other side.
Exciting times.
Mm-hmm. I bet that was hard to figure out originally.
Oh my gosh, can't even imagine.
I wonder if they could figure it out by watching this video.
I bet you could. We're going to talk to our guy, Bill Nye the Science Guy. And if you guys could pause the video here, you're going to play this through the slide deck, correct? And we're going to play this through the slide deck. We'll wait for a couple minutes for you here, and you can come back. We'll talk about the video you watched. So we can wait as you pause. And we're back.
Hey, seems like no time at all has elapsed.
Lovely.
Ooh, that looks like elephant or dinosaur toothpaste.
Absolutely, but it actually isn't, Mr. Ben. Sorry. So one of the things we're looking at is some of the characteristics you would see at the mid-ocean ridge. So you can see in this diagram off to the left, right in the middle, we've got this big plume that's coming up. And it's actually pushing up new rock right towards the center. And if you're pushing up new rock towards the center, where's the rest of the rock going to go that's already there?
I think in the video they showed the lava kind of coming up and magma kind of pushing away the rocks that were there.
Absolutely. It's got to be pushing out. So you're actually going to be diverging. You're going to be moving plates outward in the direction. And what happens, as you can see in the picture of our elephant toothpaste here, is you start making new rocks. They call them pillow basalts. And those new rocks, since they're forming underwater, they start to pillow out like that. They get those big kind of bulbous shapes. And in the picture below, you can actually see one of these old ridges that's forming. If you draw a line right down the middle, this is exactly where the ridge was forming before. So, a long time ago, these rocks were moving this way, these rocks were moving to the right. So they're spreading apart, just because of all that magma that was moving into it and spreading out.
So then kind of the pressure from the magma there would push up and thin the crust above it?
Absolutely.
Okay, so that's kind of like it was closed and then it's like broken open a little bit, and then if it squeezes a little more, that could rupture, and then wouldn't like lava come out?
Absolutely. You'd have lava come out and you'd be making your pillows right here.
If you were underwater, right?
If you were underwater, yeah.
Okay, if not, it'd be what, like Hawaii?
Yeah, absolutely.
Kind of like that. So you always see this kind of pattern at the moors. You think they got it?
I think they got it. You guys feeling okay?
We'll
Good.
find out in that mastery check.
All right. So this looks like the Earth, but it looks kind of funny. It looks like it's all mixed up, kind of jumbled up. What's going on here, Mr. Ben?
I think this is Wagner's Pangea. And so when he said all the land was together, so I think one of the things that a student should be able to do is try to figure out where the land would split. If you're looking and you see South America and Africa, we're used to seeing some land in between them. So how would that split apart? You'd have to have an opening, some force reaching up and kind of squeezing them away. And that would take millions of years. And we had millions of years since Alfred Wegener first proposed this. And so over, 150 million years ago, you'd have enough time to slide apart South America and Africa there.
And you'd have one of these mid-ocean ridges, and just like in the drawing, they'd be pushing across the other direction. So it'd take about 150 million years to get to where we are today.
Now, do you think, Mr. Baldwin, that mid-ocean ridge would go all the way up there between North America and Europe?
I absolutely think so. I think that's a really good idea. And it's almost like you're taking just about the whole length of the Earth and pushing it across. You're spreading those plates across.
So that would move everything kind of that way a little bit.
Absolutely. You're spreading it straight out.
But the surface of the Earth can't get bigger. So somewhere there must be stuff coming together. And they're probably going to learn about that in the next segment, right?
Yeah, and actually for a while they couldn't really prove this. So they're going to be learning a little bit more about not spreading them apart, but moving them together.
Sounds interesting.
You know it. Alright, so the next video we're going to watch, if we can flip to the next slide here in a sec, we are going to check out the mantle plumes and how they relate to Iceland and the spreading that happens in Iceland. Okay, so if you guys can take a second, you can pause this video right here. You're going to go up to the slide deck and press play on this video with the nice looking island that's found in the National Geographic video. So we can wait for a little bit. All right, that was a beautiful video, wasn't it?
I think it was. Now, Iceland's not on this picture, but Iceland would be located right on the moor, wouldn't it?
I'm pretty sure it would be, yeah.
Okay, and that lava that they showed coming up, that magma coming up, would kind of like be the same material coming up here.
Yeah, and wouldn't that be wild to be living right on top of that mid-ocean ridge?
That would be fascinating.
What type of things would you see in that area? Like, how would your life be different over there?
Well, we're here where we have to have hot water heaters. There you might have to have a cold water heater because all the water, when it goes through the ground, would actually get hot because the rocks would be so hot underneath you.
Wow, that'd be wild.
Could you have, with forces pushing up, do you think maybe you'd have earthquakes too?
Yeah, that absolutely could happen.
And if you were a person who was a sailor or you were fishing, you might have to worry about sometimes some of this material coming up underneath, or it could even maybe close the harbor off on you so you couldn't get your boat back home.
I bet that would happen. So let's take a minute, watch this animation, and we'll wait here while you guys pause the video. Again, you're going to go up to the slide deck, and you're going to watch this last animation we have for you guys.
And remember, you should always write these notes down.
And we're back. I hope you guys enjoyed the video. So the last thing you guys are going to do for your mastery check, you guys are going to create a Google drawing, and what you're going to do is you're going to show in this drawing a magnetic field reversal as you move away from the mid-ocean ridge. Okay, so hopefully you have the ridge in the middle, and you're going to show what it looks like as you move further away from it. Also, what you need to do is make sure to add arrows in the field showing normal and reversed polarity. So you should be able to see in that drawing which way normal and reverse was. And then the last thing, one more thing you're going to do is you're going to label your vertical cross section. So just like we saw, if we sliced down the front of it, you could see what it looks like as you went down into the mid-ocean ridge. And then the last part, show us where you would find continents. Okay, where would you find North America or South America? Where would you find, North America or Europe? Where would you find South America and Africa? So where would you find those on that mid-ocean ridge?
So it sounds like they're going to have a pretty detailed Google drawing with a lot of little things. If they had a hard time putting it on one image, could they make like a little one to the side?
You could do a little extra couple drawings in there to help it out. Yeah, absolutely.
And then finally, how did Harry Hess's data help strengthen this idea? So there should be a little writing in there too?
A little bit of a quick writing just to tell what he did and how it helped kind of prove or solidify this theory of continental drift.
And I think if they get stuck on that one, they could probably go back and watch that Bill Nye video. I think he talks about that a little more.
Absolutely, yeah.
That'd be a good place to go.
Well, good luck, guys. We'll see you tomorrow. Have fun. Go kick some butt.
And do good on your formative quiz tomorrow in class.